Hi, welcome to Module 2, Nutritional Needs of the Preterm Infant and Normative Data. Each week, we will provide tips to complete the scenario. This is a result of students giving me feedback over the last several years. They have stated that having tips to really understand the specific questions on each of the scenarios would be helpful. So I have invited Nick Gonzalez, who will be walking you through calculating for prematurity, how to use the pedia tools, and calculating growth velocity. It would be best if you go ahead and print the tip sheet out so you can calculate and write your answers to enhance learning. But before we get started, I'd first like to introduce Nick. Nick, you want to say hi to everyone?
Hi everyone, thank you for joining us. Thank you for having me, Dr. Abel.
Thank you for being here, Nick. On this slide, you have an overview of the key stages in the life of a preterm infant. These infants did not have the opportunity to remain in the womb for the entire 40 weeks of gestation, which is also term infant. A term infant is usually at 40 weeks gestational age and can be anywhere from 38 to 42 weeks. Since the last trimester is critical for many organs' maturity, this deficit of growing in the womb can result in delayed growth and maturity. Therefore, there is a need to correct for the loss of time in the womb. We call this correcting for prematurity. Many healthcare providers correct for prematurity until the age of 3, yet some correct until the age of 2 years to correspond to the change of the growth grids. The WHO growth grids are for the first 24 months of life, while the CDC go from age 2 to 18 years. So let's review some of these key terms. Gestational age is the time from the last menstrual period to the time of the expected date of delivery. Chronological age is the number of days alive since the time of birth. So you have the birth of the infant, and you count out the number of days that they are alive. The postmenstrual age is the gestational age plus the chronological age. And the corrected age is the chronological age minus the term infant, or 40 weeks minus the gestational age at birth. Okay, on this slide, I'm going to just reinforce these key terms one more time with their calculations. It's not on the slide, but gestational age is the time from the last menses to the time the infant is born, and it's reported in weeks. Chronological age is the current date, or the date of assessment, minus the birth date. It's the number of days the infant is alive. Postmenstrual age is the gestational age at birth plus the chronological age. And here I have an example. So the baby was born at 28 and 5 days. We report that as 28 and 5/7 weeks, plus 14 days that they were alive, and it would be reported as 30 and 5/7 weeks. So 30 weeks and 5 days old. The next term is corrected age, and this is postmenstrual age minus 40 weeks, the number of weeks that you would be if you were a term in gestational age. So here is an example of corrected age. It would be the PMA of 28 and 5/7 weeks plus 12 weeks. The baby was 12 weeks old, and that will equal 40 and 5/7 weeks. Now we need to correct for the prematurity, so we would take the 40 and 5/7 weeks minus that term infant of 40 weeks, and that would give us 5/7 of a week, or 5 days. This is our normative data, and these are calories and protein needs for the preterm infant to achieve normal growth rates. This is the data that you'll use to compare the intake of the infant to these numbers to see if you need to assess and alter their intake, either to get them to grow more or to get them to grow less. So let's just get oriented to the slide. In the second column is the fed recommendations, and in the third column is the parenterally fed infant recommendations, and in the third column is the protein in grams per kilogram per day. And both the enteral and parenteral units are in calories per kilogram per day. So again, I just want to highlight the daily estimated needs reported by AAP are 100 to 130 calories per kilogram for the enterally fed infant. For the parenterally fed infant, 85 to 95 calories per kilogram. And the protein are 3.5 to 4.5 grams per kilogram per day. And our units are always reported in per kilogram per day. This is very, very important to keep that information because our normative data is in those units. Many students want to multiply everything out for me, and that's actually incorrect. You want to report in the same units that your normative data is in, because that is what other healthcare professionals will know those normative data. The SPGAN is the European Society of Parental Gastro and Hematology and Nutrition. And their recommendations for enterally fed infants are 115 to 130 calories per kilogram. And the parenterally is the same, 115 to 130. And the grams of protein are 3 to 4 grams per kilo per day. And the Ziegler data is 105 to 130 calories per kilogram per day. And the parental nutrition is 90 to 110 calories per kilogram per day, and the protein is 3.5 to 4 grams per kilogram per day. The reason that the parenterally nutrition is a little bit lower, we usually recommend a 10 to 15% less because there's no digestion and there's no metabolism being utilized for digestion. So with a parenterally fed infant, it is going directly into the bloodstream. Okay, open up the PD tool, and we're going to begin to really start to understand how to use all these things. When you do open the PD tool, you're going to find that there are several growth grids and a calculator within this app. You'll be able to obtain, using the correct growth grid, whether it's Fenton for the premature, the WH is for the term infant from 0 to 24 months. And then we also have the Olsen, which will calculate the BMI for the preterm infant. So those will be the three major growth grids that we will use for this scenario. You will be able to obtain data like weight for age, length for age, OFC for age, weight for length, and BMI, their percentiles, and their Z-scores, which are going to be very, very important. You want to identify or record whether it's positive or a negative Z-score. Using the normative data will help you to assess the infant's growth velocity and the nutritional intake. And on this slide, we're going to specifically use Ziegler's data. It is divided into birth weights. So a couple things. If you have an infant that is 7 grams and you don't know which column to use, you can just use a range from 89 to 92 calories per kilogram. If you have an infant that is over 2,200 grams, we don't have any normative data for over 2,200 grams, but we can use that column to help. We can actually then also maybe even consider going and using the term data, the RDA that we use for an infant 0 to 3 months, which is 108 calories per kilogram and 2.2 grams for protein. Then let's go on down. The next row after the weight classification is the growth in grams per day. And we use grams per day for infants that correct for greater than 40 weeks. That is our normative data from the RDA, which is 25 to 35 grams per day. But for this exercise, I want you to use grams per kilogram per day. So if you were to be asked the normative data for an infant that is 900 grams, you actually report 19 to 20 grams per kilogram per day as the range. So I'm now going to turn it over to Nick, who's actually going to walk you through some examples to prepare you for the actual course scenario that you will receive a grade or points for.
Let's get started with the math then. These are some of the questions that are similar to the ones that will be on your scenarios. So yeah, I would heavily advise you to work along with me. So the first thing we're going to do is identify where this infant lies on the PD tool growth charts. So we're going to take note of his weight, length, and head circumference and move on to the PD tools. So open it on your browser and feel free to follow along with me. So the first one we're going to start with are the Fenton growth charts. And this infant is a male. We're going to skip the gestational age, and it'll actually be filled in for us in a moment. But we're just going to skip it and move on to the grams, where the question shows the grams in kilograms, but it's very important to look at the units here on PD tools, which is asking it for it in grams. So instead of 3.7 kilograms, we are doing 3,700 grams, head circumference of 34 centimeters, a length of 47 centimeters. And these two we're going to skip as well and move on to the date of birth, which is for 1. The gestation at birth is where we're going to put the gestational age of 34 into 7 days, and the analysis date of 5/13. So this is how yours is going to line up as well. We're going to go ahead and hit submit. And we see that the gestational age actually got filled in for us. And here it gives us the percentiles and z-scores of this infant at this time. So let's go ahead and jot them down on our papers. So the BMI for weight is 56% with a z-score of 0.15. The head circumference is at the 20th percentile with a z-score of negative 0.84. And for length, he is in the 2nd percentile with a z-score of negative 1.98. So Dr. Abel, do you want to touch on why the negative z-scores are important and what they mean?
The negative numbers and a negative 1.98 is relatively high. They indicate undernutrition or stunting as they go down. And the positive numbers can indicate overweight or obesity, or in the length, they would be at the upper end of the chart. They are ways to indicate the means and how much it deviates from the mean.
So let's move on to the WHO. And we're going to use the WHO growth chart, which is from 0 to 24 months, because although we haven't calculated it yet, we know that this infant is going to be at a postmenstrual age that is greater than 40 weeks. So a little more than 0 months. So we're going to go ahead and put in the values again. So we have a male. I'm going to skip the age of months. We're instead going to put in the date of birth. And then the date of measure was, again, 5/13, with a weight in kilograms this time of 3.7, 34 centimeters of head circumference, and 47 centimeters in length. And then the J at birth was 34 2/7. We have 2 charts here, and we're going to go ahead and use the second one, this 0.1 months corrected, because the second one is representing the corrected age, whereas the 1.38 months table on top is depicting the chronological age. So we're just going to take note of the percentiles and z-scores again, with the weight being in the 68th percentile with a z-score of 0.47. And the head circumference is at the 28th percentile with a z-score of negative 0.59. And lastly, the length in the 4th percentile, with a z-score of negative 1.77. And while we're here, we can also go ahead and jot down the weight for length, and he is in the 100th percentile with a z-score of 3.02.
That column that says the 50th percentile, that would be where they would need to be to grow on the 50th percentile. And the monthly is what they would need to gain each month to be at that percentile.
So they would need to be at, say, 3.46 kilograms to be at the 50th percentile?
Yes, and they're at 3.7. And if we slow down their weight to 1.17, we would be able to get them to the 50th percentile.
Okay, I didn't know that. The last thing we're going to look for from PD Tools here is going to be the BMI. And if you scroll down on PD Tools, you can find it here. It's called the Olson 2015 BMI curves for preterm infants. And once again, we're going to enter the data. We have a male. We're going to leave the gestational age blank, the weight in grams of 3,700, a length of 47 centimeters. We're going to skip these. The date of birth was 4/1. Gestation is 34 weeks and 5/7 days. And the analysis date is 5/13. So this infant has a BMI of 16.75, which puts him in the 99th percentile with a z-score of 2.17. So how come the Fenton percentiles differ from the WHO?
The reason that they differ is because of how each of those growth grids were created. Growth grids are created with data and a population that's used, and the WHO was used with term infants that are breastfed. 6 countries were used, so that was a very different population than what Fenton used of the preterm population.
The baby's length seems pretty low compared to the weight, percentile for weight, and the weight for length and BMI are also very high. So does that suggest that he may be being overfed?
That's a great question, and that's exactly why you're collecting this data, so you can start to assess. There is a word of caution, especially around lengths of the preterm infant, and to get an accurate length is very challenging to do. The babies normally curl up like they are inside the womb, and to stretch them out, you need a board length, and you really need 2 people taking those measurements, and they should take it more than one time. They should take it 2 or 3 times and do an average. So often what happens is the length is not always accurate. So you do want to be careful there. But often we do see, especially very premature infants, where we may see stunting going on, where they actually are not getting adequate intake. There has been some excellent work on this. And so weight is not always the best indicator of malnutrition, and an accurate length can actually provide a clearer picture to possibly stunning of all the organs going on inside of the body. This particular baby has both the length and the head circumferences in the negatives, these scores, and very low on the percentiles. And so this baby is actually growing not proportionate. And so they are going to actually become what we call chubby or overweight. So we do want to look at what the rate of weight gain has been, what the actual intake has been, so we can see how we can make recommendations so that we can get this infant to grow proportionately.
Well, we're definitely going to calculate that. Let's go ahead and calculate the chronological age. The chronological age is the current date minus the birth date. And remember that the current date, like Dr. Abel said, is when the measurements were taken. And in this case, it is 5/13 minus the birth date of April 1st. And we have to remember we're subtracting months here, not fractions. So May minus April is 5 minus 4, and there's 1 month in between them. And the 13 days minus the 1 day is 12 days. Now we want to convert that into days just to make it easier to work with. We're going to convert the 1 month to days, and we know that there are 30 days in April. So we'll subtract it from the birth date here. Plus the 12 days that were left over gives us 42 days divided by 7 days, just to give us the chronological age in weeks. Okay, now we're going to look at the postmenstrual age. If you forget these equations, go back and look at them, but I'm just going to write them anyway. We have the chronological age plus the gestational age, okay? And we just figured out the chronological age was 6 weeks, and the gestational age, we're going to get from up here, 34 weeks into 7 days. So adding up the weeks, that's going to give us 40 weeks and 7 days post-menstrual age. And we can actually take a look back at PD Tools, and it'll actually tell us the right answer. So up here, it tells us we have 40 weeks and 7 days, just like we found here.
Nick, that is great. Can you also explain now how to report this out in corrected age?
Of course I can. Corrected age is the PMA minus the term gestational age. And generally that would mean 40 weeks. Okay, so we're going to have the PMA, which we just calculated, of 40 weeks and 7 days, minus the term 40 weeks. And that will give us 2 days corrected age. So it's really that simple. So let's just jot these down here. Perfect. So let's move on to the next part of the question. Here we have to calculate the percentile and z-score for weight again. The difference is that this is 1 week prior, it's May 6th, and the weight was a little lower. So let's see where they were at this point in time. So we're just going to go back to Fenton and the PD tools. And we have a male. Let's skip this box. The weight in grams this time is 3,500. We're actually not going to fill out the head circumference or the length because we don't need that for this part of the question. We're just looking at weight. And we're also skipping the last menstrual period and the due date. So the date of birth is 4/1 with the gestation of 34 weeks to 7 days. And the analysis date this time is 5/6. So last week, the infant was in the 57th percentile for weight with a z-score of 0.17. And this time, we're not actually going to find the percentile from the WHO because, as we'll see in a moment, this infant is, at this date, not past the 40 weeks of postmenstrual age. They have yet to reach the 0 months of age that is a minimum for the WHO. So we're just going to move on to the chronological age, where just like last time, we're going to do the current date minus birth date. And this time our current date is 5/6 minus 4/1. The 5 minus 4 is going to give us 1 month. And the 6 days minus 1 day is 5 days. Remember, we have 30 days in April, so we're just going to convert the month to 30 days. Plus our 5 days is 35 days. So our chronological age is going to be 5 weeks. Okay, and let's determine our postmenstrual age, where we're going to write out the equation again. Chronological age plus gestational age. And we have our 5 weeks plus, back up here, 34 weeks and 7 days, 39 weeks and 7 days. In this part of the example, we're not going to calculate the corrected age because the postmenstrual age is below 40 weeks. And therefore, at this time, this current postmenstrual age would be the corrected age for the infant. Now let's go ahead and calculate the rate of weight gain. And we're going to convert all of our values to grams when we're looking for the rate of weight gain. So we're going to take the most recent weight of 3,700 grams minus the previous weight up here of 3,500 grams, which will give us a difference of 200 grams. So between this time period, he gained 200 grams. So we need to figure out the difference in time, the 5/13 from the previous date up here, minus this date of 5/6. So to determine the grams per day, we will do the 200 grams divided by 7 days for a total of 28.5 grams per day. Now, in this case, since the infant is over 40 weeks postmenstrual age, the normative data is going to be in the grams per day, and we're going to check out what the goal rate of weight gain should be in just a moment. But if this infant was under the 40 weeks of postmenstrual age, then we would have to convert this weight gain, the rate of weight gain, to grams per kilogram per day. But for now, we're good. So we're just going to add it on here. And we're going to round it to 29 grams per day. Now let's take a look at the goal rate of weight gain. For the goal rate of weight gain for this infant, we know from our previous classes that for an age of 0 to 3 months, like in this infant's case here, the goal rate of weight gain is between 25 to 35 grams per day. This infant is growing at a proper rate of weight gain. Let's just talk about their current needs then, their estimated needs. Thinking back to the RDAs that we learned from the previous class, we know that the kilocalories per kilogram per day needed for an infant of this age is 108. and he will also require 2.2 grams of protein per kilogram per day. So now that we have his goal rate of weight gain, his current rate of weight gain, and his estimated needs, let's see how this baby is growing. He is currently receiving about 110 calories per kilogram per day. Although he may be at an adequate rate of weight gain compared to the goal rate of weight gain, if we look back at the PD Tools data, we see that he is at a weight for length in the 100 percentile with a z-score of 3.02 and a BMI in the 99th percentile with a z-score of 2.19. So although he may be growing at a goal velocity, it may be possible that we still need to decrease the intake so we can lower that growth velocity to make sure that this baby won't end up overweight.
So as you're assessing this infant, it's very important that we as healthcare providers and registered dietitians get babies to grow proportionately. So not only is it important that the growth velocity is in the normative data, but just how are they growing proportionately? And this baby is definitely very overweight. Z-score of 3.02 is of concern. So we want to actually slow down the growth by actually reducing the amount of intake the baby is currently taking in by anywhere from 5 to 10%. We usually don't go higher than 10% because we don't want any kind of stunting or prohibit any kind of growth. So we usually reduce the calories, reevaluate for the rate of weight gain, and you can continue then after X amount of time to reevaluate and maybe decrease some more.
Then let's reduce his calorie intake from 5 to 10%. So if he's currently receiving 110 calories per kilogram per day, we're going to multiply that by 5%, which is 0.05, which will give us 5.5. And we're just going to subtract that 5.5 from the 110 to give us 104.5 calories per kilogram per day. And if we were to do 10%, it would be 110 calories per kilogram per day times 10%, which is 0.1. And subtracting 11 calories from 110 would give us 99 calories per kilogram per day. So this should be the recommended intake for the infant. Again, here we're going to start off with the PD tools, and I just want to encourage you guys again to work on this with me so that you understand how to do it on your own. And this time we're only going to look at the Fenton growth charts. As we will see later on, this infant does not surpass 40 weeks of postmenstrual age, so we won't be able to use the WHO growth charts, which are from 0 months to 24 months. This time I want you to do it on your own. Of course, we're going to do it too, and you can look at our answers as references, but you're on your own for this one. Here are the answers I got from the Fenton growth chart. They do seem pretty low, and the z-scores are also negative, but they do seem proportionate. But let's go on to the BMI now. And remember, for the BMI, we have to go to the Olsen growth chart. So here are the values we got for BMI, and that seems very low.
Yes, this baby is actually not growing well right now. So as we will evaluate not only the growth and the assessment of the anthropometric measurements, but we would want to assess the actual intake of the baby. And often with a premature baby, there are what we call extrauterine growth deficits. So the baby doesn't always grow as well as remained in utero.
So our chronological age is going to be, again, the current minus the birth date, in which our current date is 6/10 and the birth date is 5/12. So we're going to subtract the months again, and we get 1 month from 6 to 5. However, this time when we subtract the dates, we get a -2. 10 minus 12 is -2. So that's just telling us that the chronological age still hasn't been 1 month yet. It's actually been 2 days short of 1 month. So let's just see how many days that 1 month should be this time. And we're looking at May, and there are 31 days in May. So we're going to convert that to 31 days minus 2 days, which would be a total of 29 days. Now let's just convert that to weeks by dividing by 7 days in a week, which would give us 4 weeks and 7 days. Now the postmenstrual age again, will be the chronological age plus our gestational age. And in this case, we have 4 weeks and 1 day chronological, plus up here, the 28 weeks and 2 7 days. And add up the weeks and the days, and we get a postmenstrual age of 32 weeks and 3 7 days. So let's move on to the next part of the problem here. And this is another example from a previous date. So we need to determine where this infant lands on the growth charts. So let's go back to the Fenton PD tool. And again, you're on your own for this one. So the percentile for weight didn't change too much, although the z-score did improve a little bit. But now let's look at the chronological age again. But this time we're going to do a little shortcut. So looking back at the previous slide, the chronological age at this current date of 6/10 was 4 weeks and 1 7 days. Now look at this time period. It's June 3rd, which is 1 week prior to June 10th, of course. So we're just going to subtract 1 week from that chronological age for a total of 3 weeks and 1 7 days chronological age. For the postmenstrual age, we can also use the same logic, where on 6/10, the postmenstrual age was 32 weeks and 3 7 days. And 1 week prior to that would be 31 weeks and 3 7 days. Now we can determine the rate of weight gain, where we'll take the most current weight in grams, which was 1,200 grams from the previous slide, minus this weight of 1,000 grams, total of 200 grams. And that was over a span of 7 days. So to find out how many grams per day, we would just divide that by 7 days, because it's been 1 week, for a total of 28.5 grams per day. Now, contrary to the previous example, this infant is below the 40 weeks post-menstrual age, so the normative data will be in grams per kilogram per day. So to determine that value, we will just divide the grams per day by the current weight of the infant in kilograms, which will give us a total of 23.75. Will be rounded up to 24 grams per kilogram per day. Perfect. Now let's compare that rate of weight gain to the goal rate of weight gain from the normative data. This time we're going to look at Ziegler's chart. Just remember the weight of the infant, which was 1,200 grams. So looking at the 1,200 gram category, we see that it's between 2 different data sets. So we're going to instead make a range rather than a single number. So the goal rate of weight gain in grams per kilogram per day is going to be 18 to 19 grams per kilogram per day. So the infant is growing at a rate faster than the goal rate of weight gain. However, since the infant is plotting very low on the growth charts, I wouldn't expect that growth velocity to be too much of an issue.
No, we would look at that as catch-up growth, as long as the baby's growing proportionately. And we would also compare their actual energy and protein intake.
So for now, let's just finish up by determining the estimated needs for this infant. So let's go back to the normative data. And we're looking at these 2 ranges of the 1200s and going down here to the required intake. So for enteral nutrition, which is what we're looking at, this baby should be receiving 119 to 127 calories per kilogram per day.
Let's say this infant was actually consuming 130 calories per kilogram per day. With this rate of weight gain, might want to decrease it to within the estimated needs so that we don't have an accelerated growth velocity. But let's say the infant was actually under the 119, then we would probably maintain that caloric intake for the infant, but definitely monitoring the infant's growth and energy intake.
For protein for this infant, we will look at that range again and look down here at enteral nutrition. That will give us 3.9 to 4 grams per kilogram per day of protein. I hope you all found this very helpful, and I hope you followed along, because this is a very important fundamental for you to learn moving forward. And like I said, you're going to be using it throughout the semester. So if you didn't follow along, I would just go back and try it out yourself and test your answers compared to our answers to make sure how you did. And if you have any questions, don't forget to contact Dr. Abel, and I'm sure she'd be glad to help you.
Yeah, and I just want to re-emphasize some of the easiest details are the reason you don't get correct answer. Sometimes you put male when it should be female, or you put kilograms when it should be grams, or grams when it should be kilograms, or the gestational age of birth maybe gets missed. And so really to practice these multiple times before you actually answer the scenario in the course will help you to get a perfect score, and even more important, to learn the concepts. Thank you again, Nick, for giving up of your time and walking us through these different problems. Class, also, if you could reflect on any of this, if this was helpful, and put those in your weekly reflections, I would really appreciate hearing your feedback on having these module tips each week. Thank you, and have a great week.
Bye, everybody. Have a good week.
Bye-bye.